The next video in the mole unit is titled Molar Mass of Compounds. If you look at the learning targets, you'll actually see that these are the same learning targets as you had from the previous video. So what that means is this video will be very similar in content. In fact, there's really only one new idea that we're going to introduce here in this video. The resources for this video, we have the text, section 10.3, and then a video on YouTube. I think this is a pretty good one if you want to check that one out in addition to this video, and then some links to some different practice stuff. As the title of the video would hint at, we're going to look at the molar mass of compounds. In the last video we learned about the molar mass of elements. In this video we're going to look at how we calculate, because we do have to calculate it, the molar mass for a compound. Let's consider this example. Suppose we had 1 mole of water, 1 mole of H2O, and I want to know what is the molar mass of water. Well, if you think about the formula, if I have 1 mole of water, 1 mole of H2O, that would mean I have 2 moles of hydrogen and I have 1 mole of oxygen, because in the formula I can see there are 2 atoms of hydrogen for every molecule, so that would mean there would be 2 moles of hydrogen for every mole of water, likewise 1 mole of oxygen for every mole of water. So the molar mass then of water would simply be the mass of 2 moles of hydrogen plus the mass of 1 mole of oxygen. So if you look at your periodic table, if you look at the molar mass of hydrogen, here's hydrogen here, 1.01. To calculate the molar mass of water, I would just take 2 times the molar mass of hydrogen, which is 1.01 grams per mole, and I would add to that the mass of 1 mole of oxygen, and here's the molar mass of oxygen, 16.00. So plus 1 times 16.00 grams per mole, and this is going to give you 18.02 grams per mole. So to answer the question, what is the molar mass of oxygen? Or excuse me, not of oxygen, of water. 1 mole of water has a mass of 18.02 grams. So the moral of the story here, I'll just jot this down here, is the molar mass of a compound is the sum of the molar masses of the elements that compose it. We just add them up. That's all we have to do. So if you look down at the example problems, the first problem, it simply asks us to calculate the molar mass of each compound. So all we're going to do for these is we're going to add up the molar masses of the elements in it. That's all we have to do. Alright, so you want your periodic table handy here. If you don't have it handy, make it handy. And of course, you calculate it. The first one, we have So2, sulfur dioxide. So in this compound, there's 1 mole of sulfur. So 1 times the molar mass of sulfur, which is 32.07 grams per mole, plus 2 times the molar mass of oxygen, which is 16.00 grams per mole. When you plug this in your calculator, you don't have to worry about parentheses or anything, because your calculator will do the order of operations correctly. So in other words, when I plug this in, I'm just going to hit 1 times 32.07 plus 2 times 16.00. Don't need to worry about parentheses or anything like that. It will do the multiplications first like it should, and then add them together. And then you can see your calculator there tells you 64.07, and the units there would be grams per mole. That would be our molar mass of sulfur dioxide. Alright, next example. We have barium hydroxide. Notice here we have the parentheses, and remember from our nomenclature what this means. The parentheses tell us that this 2 subscript applies to everything inside of it. So in this compound, there's 1 mole of barium, there's 2 moles of oxygen, and there's 2 moles of hydrogen. Okay, so when we do the molar mass, it'll be 1 times the molar mass of barium, which is 137.33 grams per mole, plus 2 times the molar mass of oxygen, which is 16.00 grams per mole, plus 2 times the molar mass of hydrogen, which is 1.01 grams per mole. Alright, go ahead and plug all that in your calculator. I get 171.35 grams per mole. Alright, on C, there are no parentheses here, there's just more elements. We have 4 different elements, so we just add up the molar masses of all 4 of those multiplied by the number of moles. So we have 7 moles of carbon, so 7 times 12.01 grams per mole, plus 5 times 1.01 grams per mole, plus 3 times 14.01 grams per mole, plus 6 times 16.00. And you plug all that in your calculator. Again, you don't need to worry about parentheses, and it will do the order of operations correctly. This is 227.15 grams per mole. Alright, take a look at D, and just real quick before we worry about the calculation, ask yourself how many moles of each element are in this compound. You'll notice that there should be 3 moles of iron. The subscript 3 only applies to the iron. The parentheses here tells us that the 2 applies to everything inside the parentheses. So we have 2 moles of sulfur, and we have 8 moles of oxygen, because it would be 2 times 4, because I have 2 of this whole thing. So that's how we would get 8 moles there. So this is 3 moles of iron, so 3 times the molar mass of iron, which is 55.85 grams per mole, plus 2 times the molar mass of sulfur, which is 32.07 grams per mole, plus 8 times the molar mass of oxygen. And plug all that in. And I get 359.69 grams per mole. Alright, whenever we do these, rarely do we actually show the work like we are here. Not that that's a bad thing, as you know, we always like to show our work. The reason we usually don't is usually this isn't the point of the calculation, as we'll see here in the next examples. Usually we're calculating this to use it in a different problem, or in the problem that we're working. So as far as this is concerned, I don't need to see your work whenever you're calculating this stuff. Now, if you want to show the work, you're more than welcome to. So for example, if we were going to calculate the molar mass for E, the xenon hexafluoride, if you look at your periodic table, you'll see that xenon's molar mass is 131.29, so I can just hit 131.29 plus 6 times the molar mass of fluorine, which is 19.00, and you can see there that would be 245.29 grams per mole. Alright, the last one here, I just put this on here to remind us, don't forget diatomics. Don't forget diatomic elements. The other day we marked on our periodic tables what the diatomic elements were. The reason it's important to remember this is you're probably going to encounter situations where you're dealing with the diatomic element where it doesn't give you the formula. So, for example, if a problem asks you, what the molar mass of nitrogen gas is, well, nitrogen's diatomic, it would be N2, not just N. So that would just be 2 times the molar mass of individual or elemental nitrogen. So 2 times 14.01 grams per mole, which is equal to 28.02 grams per mole. So we get there. Alright, take a look at the practice problems. There's some more example problems we'll do here in a second. But jump to the practice problems, pause the video, and just try to do these this first practice problem, A, B, and C here. Once you're done, go ahead and start the video again. Make sure you did them correctly. Alright, for 1A, that would be 1 mole of iron, so 55.85. That would be 3 moles of nitrogen, so plus 3 times 14.01. And then it would be 9 moles of oxygen, so plus 9 times 16. That would be 241.88 grams per mole for the iron 3 nitrate. For B, that is 3 moles of nitrogen, so 3 times 14.01, plus 12 moles of hydrogen, so 12 times 1.01. That's 1 mole of phosphorus, so that is, phosphorus is 30.97, plus 4 moles of oxygen, so 4 times 16.00, that is 149.12 grams per mole. And the last one here, we just have a diatomic, chlorine Cl2, so it's 2 times the molar mass of chlorine, it's 35.45. That is 70.90. Your calculator is just going to tell you 70.9, but notice all the molar masses on your periodic table go to 2 decimal places. And what we're really doing here, we're really just adding them up. When we hit 35.45 times 2, what we're really saying is 35.45 plus 35.45. So we should be able to keep that to 2 decimal places, as you see there. Alright, the reason why we do these calculations for the molar mass of compounds is we have to use these molar masses in problems like what we saw in the last video. So if you go back to the example problems, and actually that they are here on the second page, at the top we're asked what is the mass in grams of 0.73 moles of calcium chloride. So I'm looking for how many grams of CaCl2 are equal to 0.73 moles of CaCl2. Well, from the last video, the molar mass of elements, we know that we can just look up the molar mass of the element and use that as a conversion factor. The problem here is I can't just look up the molar mass of CaCl2, I have to calculate it. So in a problem like this, you would start it just like we're showing here. You would then need to calculate what the molar mass of calcium chloride is. So the molar mass of calcium chloride would be 1 mole of calcium, so 40.08, plus 2 times the molar mass of chlorine, 35.45 times 2, and that gives you 110.98. So that's our molar mass. So I know that in 1 mole of calcium chloride, it would have a mass of 110.98 grams, CaCl2. And we've done the problem. Just have to plug it in our calculator now. 0.73 times 110.98. Oh, I left out a 1 there. 110.98. And we just get 2 sig figs here because of the 0.73. That is 81 grams CaCl2. So notice in a problem like this is what I mean where we don't usually show our work for this calculation because it's really not the point of what it is we're finding. This is why we have to know how to calculate these molar masses to use them in a problem like this. Alright, let's take a look at number 3. How many moles of aluminum hydroxide, so question mark, moles aluminum hydroxide would be AlOH3. Notice how you're not given the formula for the aluminum hydroxide. That's why we learned the nomenclature first, so that you would know what the formula is. And we want to know how many moles are in 18.5 grams of AlOH3. So again, we are going to need a molar mass of a compound. So in this compound, there's 1 mole of aluminum, that's 26.98. There are 3 moles of hydrogen, so plus 3 times 1.01. And there are 3 moles of oxygen, so plus 3 times 16.00. And we get 78.01. Notice on this problem that molar mass would go on bottom because I need the grams to cancel. So 78.01 grams of AlOH3 for every mole of AlOH3. Grams cancel. And I just need to do our problem now. 18.5 divided by 78.01. And we have 3 sig figs, that is 0.237 moles of aluminum hydroxide. Alright, last example problem. It says, find the mass. So the mass, we're not given a mass unit, so we can think grams. How many grams? Find the mass of 4.87 times 10 to the 21st oxygen molecules. Well, that would be O2, because remember, oxygen's diatomic. So how many grams of O2 are equal to 4.87 times 10 to the 21st molecules of O2? Here is a situation where we can't go directly to mass because we don't know the mass in grams of a single molecule. But what we do know is we know how many moles that would be because we can convert that to moles. I know 1 mole of O2 would contain 6.022 times 10 to the 23rd molecules of O2. Now that I'm in moles, now we can use the molar mass. The molar mass of O2 would be 2 times the molar mass of oxygen because there are 2 moles of oxygen atoms in every mole of O2. So that would be 2 times 16. That's 32. That would be our molar mass. So now it's just a matter of plugging it into our calculator. 4.87 times 10 to the 21st divided by 6.022 times 10 to the 23rd times 32. And looks like we're going to get 3 sig figs. I get 0.259 grams of O2. Alright, the only thing left here are some practice problems. So it'd be a good time to pause the video, try out the practice problems, and then start it back up and see how you did. Alright, so in the first practice problem, we're asked to find the moles of magnesium chloride. How many moles MgCl2 are equal to 0.7500 grams MgCl2. So this is just a basic gram to mole conversion. We just need the molar mass of magnesium chloride. So if we just find that, magnesium is 24.31 plus 2 times the molar mass of chlorine, which is 35.45. I get 95.21 grams MgCl2 for every mole MgCl2. Grams cancel. And to get our answer, let's see, I get 0.007877 moles MgCl2. Alright, question 3. Determine the mass in milligrams, so question mark milligrams, of 0.082 moles of ammonium carbonate. NH42CO3. Alright, so I have 0.082 moles of the NH42CO3. First thing I would want to do is convert this to grams using a molar mass. You need to calculate the molar mass. So that would be 2 times 14.01 for nitrogen, plus 8 times 1.01 for hydrogen, plus 12.01 for carbon, plus 3 times 16.00 for oxygen, and I get 96.11. So 96.11 grams of ammonium carbonate per mole. And now we're asked for this in milligrams, so I just need to convert grams to milligrams. There would be 1,000 milligrams per gram. Grams would cancel, and that would be our problem. So 0.082 times 96.11 times 1,000. We get 2 sig figs, so that would round to 7,900 milligrams of ammonium carbonate. Alright, last question. How many sulfate ions, so question mark, SO4 2- ions, sulfates SO4 2-, are in 1.00 grams of Fe2SO4 3. Alright, so the first thing we can do, if we have a mass, we can find the molar mass of this stuff. So I have 2 times the molar mass of iron, so 2 times 55.85, plus 3 times 32.07 for sulfur, plus 12 times 16.00 for oxygen. That is 399.91. So that needs to go on the bottom because the grams need to cancel. That is per mole, as a molar mass always is. Fe2SO4 3. Alright, next thing, I know how many particles there would be. The smallest particle of this whole thing, the Fe2SO4 3, that would be a formula unit. 6.022 times 10 to the 23rd formula units. Fe2SO4 3 for every mole. And then finally, we can just look at the formula and see that for every formula unit, there are 3 sulfate ions. There are 3 sulfate ions per formula unit. The formula units cancel, and we have done the problem. It's a matter of plugging it in. We have 1 divided by 399.91 times 6.022 times 10 to the 23rd times 3. Your sig figs here, the 3 doesn't count. There are exactly 3 sulfate ions for every formula unit. So it looks like we're going to be limited by that initial mass of 1.00 grams. So that's 3 sig figs. So 4.52 times 10 to the 21st sulfate ions. And there it is. And that's the end of the video.